Hello guys, welcome back to LeetCode with AK. So I'm Arvind here. So today we are going to see one of the toughest problem actually I have faced in a LeetCode. Actually, this is the graph problem, obviously. So everyone will get struggle with graph problem. So actually the graph actually before actually move into graph, we have to know the better understanding about the DFS and BFS problem as well as there are few algorithms like it is trans algorithm, there are Floyd, Wells algorithm. There are few things actually we have to know about that only then the graph will be very much easy. So okay, let's move on to this problem. And before that, guys, actually I have one request from you. Please do support me and give your comments. I have a very huge plan for creating a separate playlist for the graph tree, dynamic programming, even for the binary sets. So as well as the going forward, actually I will try to spend some time to solving the problem in LeetCode weekly contest. So that is although actually I have a plan to post in YouTube. Okay, so if you guys really interested, please give your comments. So based on the interest, actually, it will means a lot for me. So based on your interest, actually, I will create a more content and going forward. Okay, let's move on to this problem. Okay, and before that, actually, I think this week we have a LeetCode context. Okay, let's move. I will give simple. Yes, this week actually we have a one of the LeetCode contest. Actually, planning to participate this contest. So once this contest is over, okay, I'm going to create one more video for how to solve the problem in a LeetCode video context, as well as I will show you. Okay, this is a separate thing. Actually, I want to share with you. Okay, let's move on to this problem. Okay, the problem. What is the problem name? Starters part to get all the key. So what is really giving the intuition? The title. Okay, the title is clearly telling, okay, understand. I have to get all the keys. There might be a number of keys. So my the only the goal is to get all the key, but the only thing is like there might be a number of way, but I need shortest path. I have to find the shortest path to get all the key. So this is what actually I understand from the title. Okay, let's move on to this problem. Okay, what they're doing. Okay, you're giving m cross n grid. Okay, m cross n grid means that definitely there might be possibility of your rows and columns. That might be 2 cross 3 or 2 cross 4 because both your row and column definitely will be different. So that was given in the problem constraint your n lesser than okay, fine. Okay, fine. So they are giving m cross n grid where dot is representing the empty cell and as is representing the wall and at is representing your starting point. Okay. So what they are trying to say, they will give the m cross n grid. Let's say if your grid is the 2 cross 4, in that case, inside that, so there might be at the earth will representing your starting point. So where you have to start your journey. So in tree, we have a different kind of traversal, right? The pre-order, post-order, in-order traversal. So let me know if you are really want to know about the traversal in tree. I will create a separate video for that one. In meanwhile, in DFS, there are different way to traverse all of your agenda node. One is DFS, depth. Actually, you have to go deeper onto the nodes. Another one is a breadth first. The breadth wise, actually, you have to traverse to reach your target. Actually, okay. So the starting point. So this is your starting point where you have two options. One, you have to go deeper, or you have to go breadthwise. Okay. So this is the starting point. And what is that? An empty cell. So empty cell means there is no other restriction. You can go or you can move forward. Okay. What as is representing the wall. Okay, lowercase is representing key, uppercase is representing lock. Okay, that in that. So what I get, okay, that is art. The art will give you the instruction. Hey, look where you have to start. The empty cell, that there is no more restriction. You can move forward. You can move on any direction if the cell is empty. Okay, fine. What about a wall? If there is a wall, definitely you can't able to move forward, right? If there is some restriction, so you can't see like if you're staying here, that there is a only one possible way. You have to move in this direction. You can't move outside the grid, as well as you can't move this one. Okay, because this is representing as a wall. So there is some blocker here. So you can't trap. You can move to this particular cell. So meanwhile, So if we take this point, I mean 0, 1, in 0, 1, there is two possibility. One, you have to go 0, 0 or 0, 1, 0, 2. But there is no more possibility to go 1, 1. But 1, 1 is representing the wall. So that's why that is representing wall. So we have to keep this in mind, because whenever you're going to traversing your adjacent nodes in the grid, so definitely you have to consider the value of your adjacent node. If your value of the adjacent node is empty, no problem, you can move forward. If the value of the node is wall, please, we can't move forward. So please keep this in mind, because this is really important point is given in this problem. Okay, the lowercase is representing key, uppercase is representing log. Okay, fine, I am fine with that. You start a starting point on one move consists of one space in all four cardinal direction. This is really important point. Okay, so what does this mean? Let's say if you are in this point, so if you are in what I okay, wait. Let's say you're staying at this point. So your current position, this is 0, this is 1, this is 2, 0, 1, 2, 3, 4. Okay, fine. So you're staying in 1, 3. If you're staying in 1, 3, so what they are trying to say, you can possible to move in all four directions. What is all four direction? Top, bottom, left, and right, right? So why are actually I'm clearly telling here, because in graph there are in certain problem they will give you can traverse in vertical. I mean your by directional way. I mean in this way also. Okay. Yeah, so if I'm staying here, you can traverse here, you can go, there is four possibility, you can go up, go down, or left or right. In some cases, they will give you can traverse in all 8 directions. So what all 8 direction means, you can go diagonally, you can traverse this one, you can traverse this one, you can traverse this one. These are diagonal way. So, but in this problem, you can traverse only in 4 directions, up, down, up and down, and left and right. So there is no other possibility to move on diagonal way. Okay, fine. So if I'm standing in any x and y position, so I have 4 possibility. Okay, I'm fine with that. Then you can't walk outside of a grid. Okay, as well as you can't walk into the wall. Okay, you can't walk outside of the grid. You can't walk through in wall if it is blocked. Okay, that was already been explained. If you walk out the key, you can pick it up. Okay, you can't work out the lock unless you have the corresponding key. Okay, fine with that. So what I am saying, if let's say if you are in this position, so 0, 2, in 0, 2 as having the key. Okay, if you found any key, no problem, just pick it the key and move forward. But if you found anywhere in the log, so what you have to do, you have to check you have the corresponding key or not. Let's say you are in this position 2, 2. In 2, 2, yeah, there is a sorry, 2, 0. In 2, 0, you have the log. So before you are moving forward, there is a you have to check. So okay, I got the log. Actually, I have to check my packet. I have the key or not. If I have the key, just unlock that and move forward. If I don't have the key, definitely this is also be similar like a wall. You can't move forward. You can't do the breadth set for this particular cell. Okay, so keep it in mind. So empty is dot is representing empty cell. You can move forward. As is representing the wall. You can't traverse. As well as key is if you found the key, just pick it the key and move forward. As well as if you found the lock, just check your packet if you have the key or not. If you don't have the key, definitely that is also not possible to traverse. Okay, I'm pretty much sure with the problem statement what they are given. Okay, so what we have to give in that case, actually they are clearly telling there is a 6 possible way. Actually, in English alphabet, they will give lowercase is representing the key, uppercase is representing the corresponding lock. So if you get the A key, I mean lowercase a, which means the particular key will unlock uppercase A. Okay, if you found lowercase b, if you unlock uppercase b, so there is a 6 possible way. If there is 6 possibility of the character, so which means what I am trying to say, there is a 6 possibility. Only the 6 possible key will be given in the grid. Okay, and finally, we have to return lowest number of move to acquire all your key, so do you have to find out the lock, actually I'm asking the question, if I have to, do you have to find out a way to unlock the lock? No, definitely not. Okay, the only thing is I want to acquire all the key. Okay, if there is a 6 key, I have to acquire all the key. If it is possible, then return the lowest number of move. So what lowest is defining here? I said that in depth wise, actually you have to traverse your graph area, you have to traverse your grid to find out that the lowest move to acquire all the key. Okay, so I don't want to find out the uh, keys to unlock the locker. No, I have to find out a way to acquire all the keys. If not possible, definitely return -1. Okay. What this problem statement is clearly telling, I have to find out a way to acquire all the key. In that case, definitely I have to know how much key is given in the grid, right? If they are given in 2 keys, then I have to find out the all the way in depth wise. Actually, I have to traverse the grid to find out the all the way to acquire the key. Okay, that is one possibility. So I have first the very first point. Okay, I want to know what is my starting point. Okay, I want to know, right, where I have to start. Okay, as well as I want to know how much key is the grid has possessed. If the grid has possessed n key, then I have to find out the way to acquire all the n keys, right? That the very first, it's a very basic the nested loop. What you have to do? Okay, just iterate the grid. Just iterate the grid, check that your starting point. Okay, because I want to know where I have to start, as well as try to check how many keys the grid has. If the grid has the lower case, that means the keys the grid has the particular key. So the lower case is representing key. Okay, I will put it in the very first. Actually, what I have to do, you have to find out number of key, as well as you want to know about the starting point. What is your starting point at your starting point? So just iterate the grid. I will change the language settings to JavaScript. Okay, let's say this is the grid. uh, I will consider this example. Okay. Okay, before actually moving on to this step, actually, I forgot to explain this. Okay, what is the lowest number to acquire all the key? Okay, that is in this graph there, it was clearly been given 2 keys. 2 keys is being given. So I have to find us the lowest possible way to acquire all the key. The same kind of illustration actually I draw in the Excel sheet. Okay, I'm starting here. Actually, I'm moving towards the right. Okay, I can't move towards the down because there is some blocker. I mean, zero. Red is representing the wall. Red is representing the wall, and green is representing your starting point. Okay. Okay. Wait. Okay, fine. So do you have a possibility to move down? No, I don't have a possibility because there is a wall is there. So move towards your right direction. So there is one step actually I take. Just move further. Okay, I got a key. So what I said, if you get a key, just add it to your packet as well as incrementing your step. Okay, I just incrementing the step. There is step 2 is being added. I taken a step 2. Okay, move this place. Okay, step 3 is taken. Move this place. Did I have to move forward? No, I don't need to move forward. Okay, there are in particular this point. Okay, I have actually I have possibility to traverse 4 directional, right, top, bottom, and left and right. Okay, in that case, what is the adjacent node for this particular point? Only 2 node. Okay, 1 3, only 2 node. 1 1 comma 3 and 0 comma 4. Okay, I will take this. Okay, then what is adjacent node for this one? Uh, 2 comma 3 and 1 comma 4. Okay. Actually, I'm taking the step 5. Actually, which means actually I'm coming like this. Okay. Okay. Step 5 is being given. So did I have to traverse this part 2 comma 4? Definitely not. Definitely not possible because I I, I got a locker, but I don't have the particular key for that one. I have so far I have only one key in my pocket, that is yellow key. So what does it mean? So if you found any yellow lock, definitely you can unlock. Otherwise, other than that, you can't able to unlock any of the locker. Okay. Okay. I'm going towards this line. So step 6 is being taken. Step 6 is being taken. I got one of the key, 2. Okay. One of the key is 6. Wait 1 second. Sorry, actually this was okay. Second key is being taken. So totally how many keys? Totally how many keys actually I have? Okay, so totally how many keys the grid has? Only the 2 keys. So I got a 6 ways, 6 steps to take acquire all the keys. So 1, 2, 3, 4, 5, 6. The 6th way actually I got a key. Okay, let's say you have the key here. Okay, you have the key here as well as you have the lock here. Okay, so just actually I paint it as yellow. Okay, this one actually paint is as some different color. Okay, some of okay, fine. The same color actually I will do it here. So now the grid has how much key? Totally 2 keys. Actually, I will move. I will take a step. I will take a step 2. I will take a step 2. I activate the key, the yellow key. I will take a step 3, step 4, and step 5, and step 6, and step 6 actually has a yellow lock. So which means I have a yellow key in my pocket. I will unlock it. In step, I will take a step 7, empty cell. Just move forward. Step 8. In step 8, actually I got a blue key. Okay, so totally there is a 8 steps actually have been taken for this particular grid to acquire all the key. Okay, so before actually I move into the coding part, okay, now you understand about what is the problem settle, how to get the minimum possible moves, right? And the next part is like, okay, how we are traversing from, okay, you're staying here, why should I stay here? Then how should I traverse? I mean, how should I figure out the adjacent node of this particular? So in problem statement, they are clearly given there is 4 coordinates. You can direct in any 4 coordinates. So if you are staying in 0, comma 0, 0, comma, what are the 4 coordinates? 0, comma minus 1, okay, minus 0, comma minus 1 as well as no, this is 0, comma 0 and 0, comma 1, this one 1, comma 0, this is 0, comma minus 1, this is minus 1, comma 0. Okay, so definitely you can't, in problem segment what they are trying, you can't move outside of the grid. You're starting at a point, move consists of 4. You can't move, yes, you can't move outside of the grid. So these 2 points it's not a valid, these 2 points it's not a valid. So in that case, where you have to, we have only 2 directions. Okay. So in every step, what you have to do, you have to try to figure out all possible 4 direction. Okay, all possible 4 direction. If the direction is really valid, just add it to your queue. Actually, in DFS, actually what you can do in DFS, in depth first traversal. So what you can do, you can use the recursion and backtracking tracking. Recursion and backtracking tracking. Recursion and backtracking tracking to traverse all of it. In BFS, what you normally will do, you will use queues. In each time, I will try to figure out all possible 4 directions. If the direction is valid, just push it to your queue. For every iteration, just pop out, check another, just iterate all possible 4 directions. Okay. So for example, okay, I will take one of the queue. I will take one of the queue here. Okay. Uh, okay, wait. Uh, okay. Okay. Just consider this is the queue. Okay. Uh, wait. Okay. No. Wait. Okay. Just consider this is the queue. Okay. So what I'm going to, I will tell you how I am going to traverse, how I am going to traverse the position. Okay. The very first, actually, I have 0, comma 0. Actually, just push it in your queue. Okay. What you have to do, you have to just pop out. So while you have to pop out, what you have to every time, so you're popping out. So pop out a element from queue. Okay. But traverse, traverse and find all possible possible direction. Okay, add it to your queue. Okay, so once you iterate, I mean once you traverse all possible direction, then increment your stepper. Okay, this is the pseudo code for this problem. Increment a step. Okay, finally return step. If even so what you have to do, definitely you have to traverse this position till your queue got n. Okay, till your queue got n. So till your queue getting empty, you have to follow this pseudo code. So you may ask, okay, what if the queue is getting empty but you are not getting all the key? In that case, okay, you just simply return -1. So this is what actually I'm going to follow. Okay, the very first time. Okay, actually I'm pushing 0, comma 0. 0, comma 0 is my starting point. Then what is the all possible four combination? 1, comma 0, 0, comma -1, minus 1, comma 0, 0, comma 1. Only these two are really possible. Okay, 1, comma 0. Even the 1, comma 0 is not possible because it consists of wall. Okay, I can't add it to my I mean the queue. Then 0, then I will add 0, comma 1. Okay, 0, comma 1 is empty set. Okay, I will pop out, I will add 0, comma 1. Meanwhile, I will incrementing the step pad. And what is then? In 0, comma 1, only one possible the direction 0, comma 1, comma 2, not definitely not 1, comma 1 not possible. 0, comma 2 is possible. So I will add 0, comma 2. Okay. Then I will incrementing step 2. Okay, because I done with my adjustment. In 0, comma 2, what is full possible direction? So there is only one possible 0, comma 3. I will pop out, I will add 3, incrementing the stepper. In 0, comma 3, I have two possibility. One is 1, comma 1 is 1, comma 4, 1, comma 4. Another one is 0, comma 0, comma 4. Sorry, this is 1, comma 3. Another one is 0, comma 4. Okay, I increment, just incrementing a stepper because actually I'm done. Sorry, not incrementing a stepper because actually I'm done with this part. Okay, just and then move forward. Just pop out. Just pop out. Just pop out. What is all possible four direction? 2, comma 2, comma 3 and 1, comma 4. Okay, then still I am not still I did it. So while I am in 0, comma 3, I have two possibility. Still I done with that possibility. So 0, what is 0, comma 4? Just pop out 0, comma 4. Just pop out 0, comma 4. Add the possible direction. So 1, comma 4. So incrementing the stepper 1, 4. Then pop out 2, comma 3. Before popping out 2, comma 3, just check what is all possible fourth direction. uh, Actually, the possible fourth direction is 2, comma 3. Okay, just add it to 2, comma 3. 2, comma 3, definitely you can't move forward because there is a lock over there. Just implementing the stepper. So between 1, 2, 3, 4, 5. Currently, you are in this position. Okay, just pop out 1, comma 4. For just 1, comma 4. In 1, comma 4, actually, I have four possible direction. Three possible direction. 1, 2, 3. But the 2, comma 4 is locked. I can't move forward. 1, comma 3 already been visited. 0, comma been already visited. So no, just pop out. Don't add any value because these nodes are already been visited. Okay. Again, 2, comma. Okay, this has been already visited. Okay, I'm in this question. Okay. Just pop out 2, comma 3 in 2, comma 2. Sorry, 2, comma 2. Just pop out 2, comma 2, 2, comma 2. Before popping out 2, comma 2, just check the all four possibilities. So only one valid node, 0, comma 1. So 0, comma 1. Sorry, 2, comma 1, 2, comma 1. Just implementing the stepper. 1, 2, 3, 4, 5, 6, 7. Implementing the step. Okay. Okay. Finally, where I'm here. Okay, I'm here. Okay. 2, comma 1. What is all possible four direction? Okay. the wall is the upper one is consist of wall. You can't move forward. The lower one definitely out of the bound. The left part, the right part is locker. Already I've been traversed. Don't worry about the left part is key. Okay, just add 2 comma 2. Okay, just add 2 comma 2, incrementing the stepper. Just in 2 comma 2 already you have been traversed. Okay, already you have been traversed. You got all the key. So totally there is 8 steps. So every time you have to follow this pseudo code. Just add the values to your queue. Just add the value to your queue. Before adding the value, you could just check it is been visited or not. If it is not visited, just add it to your queue. So in graph, definitely I need two things. One, I need queue, and then another one I need visitor array. So why I need visitor array? Because definitely in gap you don't want to visit the node again and again, again and again. So that's why in order to restrict that repetitive traversal. So what I actually I'm keeping the visitor node. Okay, the third thing what you have to do, you have to know number of key as well as your starting point. So as well as your starting point. So every time actually check Ajax and node. Your Ajax and node should not visited. Okay, your Ajax and node should not having wall. Your Ajax and node okay, fine. If your Ajax and node should not having having lock. So it may have lock, but it should not having lock when you didn't have corresponding keys. In that case, definitely you can't move forward. This is the possible way you can't move forward. Let's move on to this the problems and code block. Actually, we clearly will get how to traverse this one. Okay, the very first step, actually, what I said, okay, just figure out the number of key as well as your starting point. So what I did, actually, I traversed a node, at is representing my the starting position. Just check for every traversal, actually, check whether the particular grid of I comma j is consisting of if I comma j is consisting of at, then actually I'm taking that is my I'm considering that is my starting point. Okay, this is my starting point. Meanwhile, if any grid I comma j contains lower letters from A to F, why I'm saying A to F? They say there is one six possibility: A, B, C, D, E, F. Only six possibility. So I'm checking is there any other grid I comma j having this six possibility? If having this six possibility, then I will incrementing the number of keys. Okay. So I got 2 points. I got number of keys as well as I got the starting position. Then move forward. What I say. I need a key as well as I need a visitor array. Just move your so what I did, just move your I mean the starting position to your queue. The very first point, actually, what I did, actually, I keep 0, comma 0 in my queue as well as I mark 0, comma 0 as visitor. Okay, the same thing. Actually, x comma y, it's axis, the starting position axis. So I will add a, x comma y to my visitor array as well as I add the x comma y, my starting point to my queue. Every step, actually, what I'm doing just checking is the number of key equal to 0. Just return the step. Okay, why I'm doing that? Every time actually you're traversing your Ajax node, try to check. Okay, try to check if number of keys 0, which means if you means you active all the keys, just return the stepper. If not, move forward to find out the all possible direction, top bound, left and right. Okay, so this is the directional. So if you are staying in I comma, so this is what actually they are clearly mentioning. If you are in 0 comma 0, the top one is minus 1 comma 0 and bottom is 1 comma 0. So which means if you are in 1 comma 0, 1 comma 1, what you have to do, you have to add this. You have to add this. If you are 1 comma 1, your topmost, the top, I mean your upper bound axis is just add 1 comma 1 plus minus 1 comma 0, 1 comma 0, which means 0 comma 1. Okay, that is what's actually given here. This is a possible direction in every cell. If you want to figure out the adjacent value, just add this. If you add this one, you will get top. If you add this one, you will get the bottommost. If you add it, this is left and this is right. Okay, just actually I'm trying to iterating this array, adding this direction, possible direction to my particular node. Then I will get the top, bottom, left, and right. Check two things. My top, left, and bottom definitely should not be out of the grid. I mean, should not out of the bound. So I'm just checking. It should not out of the bound condition. This is out of the bound condition. Out of the bound condition. If my new x and y axis is not out of the bound, just check. Is this already been visited? If it is already been visited, please move away, because I already done with this part. Why should I? Okay, I already been done. Okay, just just move on to the next possibility. In the next possibility, what you are doing, okay, checking, okay, is contains a wall. If it is not, definitely I not. Okay, two condition. One, if it is already visited, I can't move forward. Another one is if it is consist wall, definitely I can't move forward. Then what is the third step? Okay, the third step, it may contain keys or it may contain block. If it is contain key, no problem. Just add it to your pocket. The pocket, what is representing here? The set data structure. Actually, I'm keeping the set data structure here. Okay, just I add my key to my set data structure. Meanwhile, actually decrementing the key count, because I want to acquire all the key. I have a two key. I just want to figure out a two key. If you found out the one key, just decrementing the pointer. So what does it mean? Going forward, you have to figure out only one key. Just mark this as array visitor. Just add this to your cube, because this is one of the possible coordinates. I mean the possible adjacent node for your I comma j. Okay, if your grid I comma j are being locked, just check your I comma j as a proper key in your set, because set is nothing but actually it's a pocket. Actually, it's a separate data structure. Actually, I'm considering that as a pocket. Wherever I found a key, just add it to my pocket. Okay, if I found a lock, okay, I will check in my packet whether my key, particular corresponding key has appear or not. If not, okay, definitely that is also not possible to move forward. I'm just checking the set data structure as key or not. If it is as a key, just delete that key. Okay, which means I will unlock that. Meanwhile, mark this array visitor, as well as this is also one of the possible adjacent node to move forward. Okay, if I didn't have the corresponding key, definitely that is not possible to move forward. In some cases, there might be empty cell. Empty cell means there is no restriction, just move forward. No restriction, move forward. But before moving to any empty cell, just check it is already been visited or not. But we done this. Okay, I will respond with. Okay. But the visited array set is been already been done in line for 47 and 47 to 49. So there is just add this to visited array as well as add it to queue. Okay. Once you iterating the all possible four combination, finally you can incrementing the stepper, which is listed in last. Okay. So meanwhile, for every time, actually, I'm moving to for figuring the adjacent node, I will check the what is the number of status, number of keys. The number of key is 0, definitely I will return stepper. Okay. Meanwhile, if there is no, if the array is empty, as well as my if my array is empty, I mean my queue is getting empty, as well as my number of key is also not getting 0. In that case, there are more possible keys. There are more number of keys in the grid, but somehow you got stuck to find one of the keys. So that's why actually I'm returning -1 here. So guys, this is really very simple. The breadth first traversal. So just one thing, actually, you have to keep it reminder. If you don't know about DFS and BFS, please do your comment. Actually, I will try to teach you what is DFS and BFS. In BFS, you have to keep one queue, add your starting point. Okay, iterate, find all possible four combination. If all possible four combination is really valid, just add it to your queue. Before you are adding to your queue, what you have to do? You have to mark this as visitor, which will restrict going forward, visiting the same node again and again. If it is having a key, just deduct your number of keys. If it is having lock, just unlock and move forward. This is the very simple. So I will write the pseudo code. This is the pseudo code. So I will write the pseudo code once again. Okay. So first, find number of keys as well as starting point. Okay, and then use okay, just push it to queue, as well as mark as visitor. And every time you have to iterate your queue till it getting empty. Find find what you have to do. Find find all possible core combinations. Okay, check the node, check that is valid or not. How to check valid or not? If should not contains wall, if should not contains not contain should not contain lock, having no corresponding key, as well as already visited node. If this is really valid, just add it to queue, mark as visitor. If it is having key, same condition, add it to queue, mark as visitor. Meanwhile, decrement number of keys. Okay, okay. Finally, what you have to do? You have to, once you find all this, what you have to increment step. Finally, return -1. So meanwhile, in every finding all possible, just check what is the number of keys. Number of keys equal to 0. Then return the step. Very simple, very simple. So what is the time and space complexity? The time and space complexity, you don't worry about the depth first, just worry about in very first, actually I'm trying to iterating in my m cross n grid to finding out the starting point as well as my number of keys. So definitely this is the one of the worst case time complexity. The time complexity would be O of n comma n cross n, as well as I'm creating a separate set data structure for storing all the keys. So the space complexity, definitely the auxiliary space complexity would be I have to traverse all the nodes. So auxiliary space complexity also O of n cross n, because I have to keep all the nodes in my queue, right? The meanwhile, there is some in the set also take this separate space complexity. So how much time the set will take? Definitely, you have to mark all the nodes. In worst case, let's see. Okay, this is your starting point. You are placing your keys, here. In that case, you have to traverse all the points, right? In that case, set also is considered of n cross n space. Okay, so this is the space complexity. Key also takes some auxiliary space complexity, and your time complexity of n cross n to finding out the starting point and number of key. Finding out, okay, guys, if you run this problem, definitely it will solve very basic test cases, but somehow, okay, actually, okay, it will solve all. Okay, I'm trying to submitting here, but it's getting failed in one of the test case. Okay, just this is part one. Okay, in part two, I will tell you why this test case is getting failed. I will clearly illustrate you, because there is some edge case we fail to understand. My intuition is really failed to understand these edge cases. In part two, I will clearly understand why my very basic problem is getting failed for this test case. The in part two, I will clearly understand. I will tell you how to solve this problem, how to consider these edge cases. Okay, please stick with me in part two. Thank you so much for watching this video, guys. Please give your comments. If you really like your video, please share it in LinkedIn and wherever is possible. So thank you so much. So I will meet you on tomorrow. So thank you so much, guys.